I'm the president of the Canadian Meteorological and Oceanographic Society, and it's my pleasure to chair the fall tour speaker. Those of you may recall that in the spring, we were pleased to have Eric Oliver speak as our first part of the year tour speakers, so part 1 and part 2. And Eric talked about Indigenous knowledge systems, and Eric's an oceanographer at Dal, and both Eric and Robert actually presented the public talk at our Congress, virtual Congress out of Saskatoon. I'm joining you from Chipuktuk, which is in Halifax. We are in the ancestral and territorial lands of the Mi'kmaq, and I'm pleased to be with you today on a somewhat cloudy but chilly day, but there's no snow on the ground here in Mi'kmaq. Just a couple of reminders. The questions and answers, if you could put them in the chat, and we'll have 15 or 20 minutes for questions at the end of Robert's talk. La présentation sera uniquement en anglais, mais Robert et moi sont capables de lire ou comprendre le français. Si vous voulez poser des questions en français, ça va être correct, et puis on va répondre en anglais. A couple of reminders for CMOS members and others. It's time to consider or renew your membership. We've done a lot of work to have a lot of really interesting webinars, both out of the centers and nationally this year. We're going to have our first in-person, it'll be actually a hybrid meeting. Our Congress in 2023 will be in St. John's, Newfoundland. We're really busy planning the Congress right now. It'll May 28th to the 1st of June, so put that in your calendars. It will be a hybrid, as I said, but we're really excited to have an in-person component for the first time in several years. As well, Gordon just put out the release the announcement for nominations for awards and scholarships. It's really important for us in the CMOS community, but others are welcome to consider those. The prizes and awards are listed on the CMOS website, so please consider nominating folks for scholarships and awards. It's a really important part of what we do in CMOS. I will now take the pleasure of introducing Robert. Robert is of Inuit descent from Nunatsiavut, which is in central Labrador. He's currently an assistant professor in Kingston at Queen's University, and he leads the Northern Environmental Geoscience Lab in the Department of Geography there. He's joining us from Kingston. Last time I had the pleasure of talking to Robert, he was actually in Goose Bay, Labrador. His research program is really understanding and predicting the impacts of climate change in northern communities and ecosystems, and of course, particularly in northern parts of Labrador. And as an Indigenous Northerner and researcher, his experiences and relationships in the community have really shaped the 10 years or more than 10 years that he's working on issues related to climate change in Labrador. I've been a Twitter friend of Robert for a number of years. You can find Robert on Twitter as Labrador Ice. I encourage you to follow Robert. He's an entertaining tweeter, and I certainly enjoy his submissions, and I've enjoyed some of the media articles. I certainly one on Globe and Mail he may allude to in today's presentation, and Robert's presentation today is on climate services in Canada's North. Are we doing enough? And I'll turn it over to you, Robert.
So I wanted to start by thanking you, Jim, for all your help in putting this together and inviting me out to do this, but also just all your support over the years. And, I've kind of alluded to before, we've had some rough stuff the last couple of years, and you've been really great about everything. So I certainly appreciate that. And I really want to also thank CMOS for the opportunity to talk today. You did a good job introducing my talk and background, so I'll probably go through, I got a little introduction that I'll go through, but before getting into more content stuff. But I do want to start at the outset by acknowledging a huge number of partners and organizations that have supported the work that our lab and that I did through schooling over the years, and some of the stuff directly linking to this presentation, but others just organizations, especially Nunatsiavut and Parks Canada, who've been like really close partners in a lot of work, and especially in the northernmost parts of Northern Labrador. But I also want to mention, partnerships with the Arctic Net Government of Canada, Newfoundland Labrador, who have helped with some of the weather station stuff that I might get a chance to get to. We'll see how the timing goes. I also want to thank, I could have just a huge number of these. I could have about 3 or 4 slides of just names of people, but there's been a lot of academic research collaborators over the years, a lot of community members, a lot of people with Indigenous governments, especially the Inuit government in Northern Labrador at Nunatsiavut, who we've partnered with. And I kind of want to particularly mention Rod Lang, Michelle Saunders, Carla Pamek, and Jim Gowdy have been very helpful. And I also want to say, a thank you to all the members of our lab, past and present, who've undoubtedly contributed in any number of ways to the work that we do. And so I'm not going to go through all the names, but I just want to mention that and their important contribution to our work. For myself, I'm born and raised in Happy Valley Goose Bay, which is in central Labrador. But my Labrador family is largely I consider myself as, there's a term, Hadunangayuk, which is basically descendants of the first settlers of the coast of Labrador who married into Inuit families and lived on the land there. And so my connections is to both, some parts of kind of southern and some parts of northern, and I'm connected through Nunatsiavut, and these are just kind of some of the areas on the map where my family is connected through. Now, in terms of academic paths, I, kind of, it looks all clean when you put it on a PowerPoint like this. So you do your undergrad and then you master's and PhD. But there's been a lot of challenges there, and a lot of ups and downs. A lot of times maybe where I wasn't gonna go that route, but that's how it went. And in my undergrad, I was doing a lot of northern and climate work, then did glacier work in Northern Labrador, and then permafrost in the doctorate. And I did a postdoc at the Labrador Institute, which was called at the time, on kind of shrub permafrost snow interactions. And since 2018, I've been a prof at Queen's, and we have this research lab that looks at climate change impacts on Northern Canada. This topic about Northern climate change, I started to get into it, aside from just personal experience with it, I started to get into it largely from the perspective of some of the climate data stuff we was working with. And some of you may know or may not know, but years ago, almost 10 years now, which is making me feel a little old, but anyways, we had a paper that ended up being, I think it was pretty high profile at the time, and it was looking at global temperature records and how do we deal with areas in the north. And so we had come up with some techniques to try and fill in the gaps in some of the global temperature records. And one of that kind of put my eye towards some of the challenges around climate, and we'll get into climate services in the north, just having those experiences with that type of work and the difficulties you run into. One of the things that we are a bit proud of is that, in the time since this work, all the major kind of global temperature providers have all started to use ways to try and better deal with the north. And we like to think that we at least played a small part in that. So I'm going to start by saying that, climate change, although, in my region, the area has obviously been experiencing change for a long time, manifesting at a personal level, and like where myself and people in our communities can really say they experience climate change has largely been some of the extreme events in the wintertime. And some of those extreme events have basically cut off traditional trail routes in really extreme years, so really warm winters. And this is an example of a notice that was placed up in 2021 in January along like the most heavily trafficked route between communities, mentioning basically that the ice was not good and along this route, and that was a real problem. And this has been occurring more and more, where you have challenges like even the groomers that support some of these trails between the communities going through the ice. And luckily in this case nobody was injured, but there's been some pretty big close calls, and sadly there every now and then there is somebody who goes through the ice and passes away, and that becomes more common in years where conditions are above average. So I think that looking at some of these extreme events and thinking about climate change through the lens of them has certainly shaped the way I think about even understanding climate services in the North. And so I figure I'll introduce the definition. So I mentioned the talks about climate services, and there's a lot of academic style definitions out there. I'm just going to say it, in the way it's mostly used, it's talking about like climate information and products that help to inform us in relation to challenges with climate change, really. And hopefully make good decisions when it comes to climate adaptation, hazards, and risks. They do, climate services can correspond to whether we're talking about like the provision of the climate data, or even taking existing products, existing information, and tailoring it in a way that can support making better climate related decisions. Now, I'm going to say something, I guess it could be controversial in some circles. I'm going to call it my hot take, that meteorological services are climate services. Because climate change is manifesting, especially in northern areas, so much in the form of extreme events, there's no way to inherently separate out the provision of meteorological services from this overarching goal of climate services. One cannot be done effectively without the other. And I think that it's important to start thinking about that paradigm, and for CMOS to even think about, it's how it thinks about climate services in terms of meteorological work as well, and weather stuff. So one of the things with this new kind of discussion around climate services, and when I went through schooling, I took a lot of climate change courses. Climate services didn't really come up. It's kind of a newer phenomena. In Canada, the largest provider of climate services is the Canadian Centre for Climate Services, which is newly created. It hasn't been around that long, and it's really intended on hopefully providing climate information that helps to inform climate adaptation in communities across Canada. And it's a lofty goal, but they've done a lot of work since being launched, and so in a few years it's really added a lot to the Canadian discussions around this, and hopefully that continues kind of into the future. And primarily the Canadian Climate Services from a government perspective is delivered through three main portals, and the one that people are, I think, getting shared around more lately is this climate data .ca site. And so climatedata.ca, I'm just going to provide it's like a short how-to. You can go to the website, you can click on a variable, whether you go like the hottest day of the year, and you kind of click a couple windows, and it gives you a graph, or it gives you a map of Canada that you then can kind of pick a different grid cell. And once you click on it, you end up with a historical representation of change in that location. And the things that are provided there include whether it be climate model simulations or historical climate model runs, but also there's gridded climate data, so historical observations. And one of the things I do want to call your attention to here, I want to pause it for a second. You see these future climate scenarios, and then you see these historical climate scenarios, and you see the historical data, and you'll notice that the historical data seems to vary more than the model data. And that's something to think about. We see in this case, the hottest day in, this time in the 1950s is like around what's not projected till way later into the later in the century. And that's just, something that's something you should be cognizant of, that when people are using these things, these models and stuff, they don't include quite the true extent of variability that we often see in kind of the historical records. And so that's just something to kind of think about as moving forward with some of these products. But in terms of the North, it's really good in that you can kind of go and navigate around all these areas, and you can click on the grid cell for Iqaluit, and you can get this past and future trajectory. And being someone who worked a lot doing climate stuff and thinking about how that interacts with communities, this type of data would have been really hard to get access to even like 5-10 years ago. Like, you would have had very specific expertise needed, versus in this case, you can just go click on the map and you download the data, and that's great in that case. The challenge is, and this is something that I'm going to kind of allude to quite a bit throughout this talk. Sometimes that being easy doesn't necessarily mean that we are getting what we need, especially in terms of in the North. And recently there was a project that was put together by the Northern Climate Data Working Group, where they did an inventory of all the climate data in the North and the climate projections for the Canadian North. And for full disclosure, I was asked to be part of it and kind of stepped away over some differences in terms of Northern inclusion. But, they did produce a really big comprehensive document that's got a lot of information out there for individuals who are interested in some of the sources that are out there. But one of the things in taking this big working group and looking through the available information that they came out to and they kind of recommended, was they said basically that, despite the fact that a lot of people use these kind of like gridded products covering all of the Canadian North, they should be approached cautiously. And considering that's what's being provided and told to communities, that you should be using this information, and that this information is there to support, climate adaptation in your communities, to have at the same time kind of the regional or, experts on that kind of data saying, ooh, you should, kind of be careful in using those kinds of sources. That does put a little bit of a challenge there. And so, in thinking about what should be used by groups trying to understand how the climate has changed in their area and how it will change in the future, the working group kind of recommended that instead of using these like gridded products, that you use products that have been corrected. And I should mention that that's kind of been brought up a couple times before. There's been a couple of papers. I was involved in one, and there's a lot of that have actually brought it up, but focused on the Canadian North, where we kind of said, you got to be careful with these gridded things, and you got to use more high quality information, or else you can run into issues. And so their primary recommendation was to use this data set. It's called AHCCD, and it's called the Adjusted and Homogenized Canadian Climate Data. And I'm going to talk a little bit about that, because, if you've got this working group saying to people that this is the information you should use, then, and especially in the North because of known issues, then maybe that deserves a little bit of a deeper dive. And so this word homogenization comes up a lot in the academic literature. It really just means corrected. And so what that means is that these records are basically ones that have been corrected for, like, you take a station and you move it from one spot to another, and sometimes you need to do corrections between them. You might have a change in the measuring equipment, or, you know, the time of day that certain measurements are taken. And if you don't take those corrections into play, you might have some challenges with the data later. And homogenization, these corrections, usually is based on what it says with the station. You know, if it says, oh, we moved this station from this location to that location at this date and time, then, you know, obviously you would use that to help adjust the station if you need to. But more commonly now, you need to have kind of like a network of nearby stations that can help you detect things, because, you know, people is bad at writing down notes, and I can certainly attest to that myself. So they need to have other ways of detecting when issues come up that maybe aren't written down, for instance, or that there's not an easy way to correct for it. And so that's kind of the intent with these homogenization products. And so, like, here's an example. These are some Canadian examples. You can see there's 3 different colors on here, and this is just a station where, you know, one station operated by one source up to a certain point, then another group took over, then another group, then another group. And so, you know, the homogenization process, the correction process, just involved, in this case, just stitching together these stations so that you get a long-term record, the kind you need to say how much has it changed, and then hopefully use that to inform the future. In the case of, there's other examples that are more prominent. And so in this case, there's 2 graphs here, and the dotted is kind of like the original information, and the colors is like the corrected information. And in the one on the left, you can see that if you just use the dotted information, you'd probably be seeing a bigger trend over time, where after correcting, it kind of reduces the trend. And so what that means in this case is it's saying that actually, you know, annual maximum temperatures reaching a certain height happen more common than you'd expect. So that can help you thinking about, like, what kind of extremes you might experience in the future. In the case of the one on the right, you know, there's clearly a very clear discontinuity there that was introduced, and so they had to correct for that, so that you can kind of get a continuous record. And so, you know, this is kind of one of the challenges if you use raw information without these corrections. If you know, picture that one on the right and trying to do some sort of analysis of it, obviously you can end up in running into real problematic issues there. So one of the things that I wanted to highlight is there was actually a recent paper that was looking at California and kind of dealing with some of these same issues. And one of the things they had said was, so in California, there was all this talk about how they were getting different climate trends along the coast from in the inland area. And what does this mean for trying to think about what we got to adapt to in the future? And what it turned out was, it was just that the ones in the interior were corrected and the ones along the coast weren't. And so, you know, there was this whole research paradigm that was just being shaped by the fact that you know, some data was corrected and some wasn't. So this can kind of really matter when we think about delivering climate services. So that kind of leads me to, so a lot of groups are trying to determine, like, automated ways. And, you know, there's an example on the left from Berkeley Earth, and, like, they take all these different pieces and they try and piece it together into some continuous record. But you know, with some stations, like it's showing, they can be, you know, it's a pretty challenging issue, and for others it's less so. Does this kind of stuff apply to Canada? I showed a couple examples earlier, but here's a map that shows for different stations that they looked at in Vincent et al. The ones with colors on them are the ones that needed corrections. And on the left, it was Tmax, so maximum temperature on the right, it was minimum temperature. And so what this is saying is it's a pretty prominent issue, and there are some of those points in the north, right? So when we think about delivering northern climate services, if we're trying to really understand what kind of climate future we got to prepare for, then we got to make sure that we're not using information that has these biases in them uncorrected. And in the US, they've actually done a lot to try and set up a network that can help protect against this. So they've got the US Climate Reference Network that where they've set up all these like really high quality stations all across the continental US and even across Alaska, and they're still installing sites in Alaska. And all these stations have basically all the measurements you would think of. Some of them are done in parallel, and some of them have been operating almost 20 years now, or 18 years. And this is meant to be like, they wanted a really, really high quality network so that they could detect when there's issues, and that they could learn how to correct for these things in their other stations. And that's really enabled them to, I think, be kind of world leaders in some of that stuff. And so where this kind of comes back to with the climate services and the stuff I was talking about with the climate data site, if we go back to that gridded product that being shared around and that people are recommended to use, that's not homogenized data. So that is using the raw data. There are some quality control stuff, but that is not homogenized across Canada. So what that means is all those corrections we're talking about are not in there, and that introduces a lot of potential for maladaptation in some ways. Maladaptation being maybe preparing for a climate that's not coming. So if we go back to the recommendations we had from the Northern Climate Working Group, it was basically to be really cautious about using gridded kind of these, complete data sets. And they said to use this other one instead because it's corrected. And right now, the main, the main resource that we're being asked to point people to doesn't use either of those in that case. Now it seems like a pretty easy solution, right? Like you figure out a way to incorporate the better quality data into this, and then you can correct the problem, and then you don't have like these issues kind of filtering out all across Canada. So why don't we take a look at this like really good quality data set for the North, the adjusted and homogenized climate data. And you can kind of go see there's a bunch of different options. You can use air temperature, precipitation, pressure, and wind. And if you want to get it for daily stuff, you got to go to kind of something like a website that's like an FTP site. And what you'll see on there is that for precipitation, for rain, snow, and total precipitation, the last update was in 2017. So these in the US, these homogenized products, these corrected products are being provided like, in kind of about a month delay in some cases quicker. In Canada, we haven't had an update for precipitation in almost 5 years. For temperature, we've got it to the end of 2021. Once a year, they do an update and they add the whole previous year. So, that's a lot more timely, but clearly there's a big difference between what's being provided temperature versus precipitation. You'll note that there's no mention of wind speed here, which is really important. And there's no mention of pressure because those are not available in daily format, but also from what I understand I think wind speed, it hasn't been done since 2015 or 2014. And for surface pressure, maybe around the same time as well. So we've got, at the same time as, we've got groups saying, well, you need to use this information, but it's not there for the communities and for kind of regional experts to even be able to use. So they kind of use what they got access to. So that was challenge one, like how available is that, really high quality data set. Challenge two is what's its coverage like, across Canada. And so this is a map showing the locations of every corrected precipitation monitoring location. So all these high quality ones across Canada that is available in the record. And this is every one that's ever been available. And so you can already see the pattern emerging that there's, by the way, I've got a 50-kilometer buffer around all of these. But you can see the pattern that's emerging right there, right? Like that you got a lot of stations in the south and not very much in the north. And that's kind of a prevalent pattern for those people who do a lot of work on climate stuff in northern Canada. You kind of get used to seeing that this idea that we really don't have the products that we would expect in that case. Now, I wanted to highlight something. So these are the communities in Canada that are the most remote. The communities that are eligible for the Nutrition North program. You'll note that it includes all of the communities in Inuit Nunaat, which means that we have, essentially all of the Inuit regions are comprised of communities that are eligible for this program and are considered the most remote in Canada. And you've got all kinds of other communities that are Indigenous as well. And if we take those communities, and these are often fly-in communities, most of them are fly-in communities or seasonally have access issues, and we superimpose them on where we have this good long-term high quality information about precipitation, you can kind of see that there's a lot of gaps there. That a lot of the most remote communities, the communities that have the most issues with accessibility, not only do they not currently have access to like recent information like this, but this is showing every location that's ever been done and corrected. And so they don't even have like past in most of these cases. And the ones that are within 50 kilometer are highlighted here in yellow. And so these are the locations that actually are within 50 kilometers of a site where we actually have this good quality precipitation data for. And it's about 35% of the Nutrition North communities. And even if I expand that buffer to 100 kilometers, we're still talking only about half having actual climate information being collected within their realm, within their region that is considered suitable for looking at climate change. The story is better for temperature. So I don't want to, the precipitation we have less of, temperature it's much better. So the numbers do get better. I think it's like 60% within 50 kilometers have had at some point, but it's still not, it's not a great picture, and you can certainly see that. So that's what coverage is like. Now we're going to get into what's it like through time. So that's like the geographic. Now we're talking about temporally. Years ago, we wrote a paper that was looking at like these high quality observations. Where do we, how many do we have through time, and like what kind of impact does it have? And we had noticed that like there was a massive drop off in all this in the stations after the 2000s, and that drop off was also in like, kind of the far north in particular. You could see it, and you can kind of see the difference on these two graphs here between all the stations and the northern stations. However, some of those issues that we brought up at the time have been corrected in the time since to some degree. I mean, you still have very few in the north, so like that hasn't changed. But some of the like tremendous work being done by Lucy Vincent's group at Environment Canada has basically hauled in extra sources and tried to to throw together more corrected data. And so that huge decline in the corrected information is not quite as bad as it was before. This is what it looks like for temperature since the records begin for daily temperature. This is how many stations are reporting that quality controlled information. And so, you can see that there still is a decline, but we're not talking about the same level of decline before where it like plummeted. We're basically back to having as many really high quality observations as we had in the 1950s, after kind of a period of time where there was a lot more. So that doesn't look, I mean, it's not perfect, but it doesn't look as bad as the previous graphic I showed. But for precipitation, it gets pretty bad. And so this is a real problem, obviously. And it's, there's a lot of reasons behind it, but suffice to say, when we're saying that in the corrected data, the data you're supposed to use to understand how the climate's changing, what it is in the future, especially for something like precipitation, where like extreme precipitation events are, quite a likely part of the future, to be essentially having as much information as back, 100 years ago is not great, obviously. And so, it does kind of leave us in a challenging spot. We got all these friendly portals for climate services that are intended to help communities. And, our best guidance at this point is that we got to provide carefully corrected information to these communities in order for them to actually prepare for the climate future they're going to experience, and understand what kinds of extremes that are going to be there. However, I'll call the good stuff is out of date, unevenly distributed geographically and through time. And that leaves us in a challenge because, let's say you find another alternative kind of information you're trying to use, but how do you even evaluate whether that's suitable if you don't have access to this high quality stuff? Like, how can you decide if another product actually is good or not? So this climate services problem that disproportionately impacts the North, how can we fix that problem? And can we? And, what I've looked into at this point is that, we can to some degree, but there is a bit of a problem here. And so I'm going to provide a bit of an explanation of where the problem is. And, I'm going to go to the Environment Canada archives of all their climate information that they provide available. And so this is everything from, short chopped up little stations to stuff that needs major corrections to stuff that was operating for, a year. But I'm going to go back to that. And I'm going to basically look at the ones north of about 55 north, just to give it's easier to use a latitudinal cutoff. And, the dots are all the different stations that have ever reported anything since the records began in Canada in the entire archive. And so we're going to look north of 50 in this case, or north of 55 in this case. And I'm looking at 5 things. So I'm looking to see how many stations report these 5 variables. Temperature. Is it raining? So rainfall. Is it snowing? Snowfall. Wind and snow depth. And this is just based on, you read enough literature about what people think about when they're on the land, what helps them understand what they're going to need information wise. And I think this is a good 5 variable subset to use. And if I look through that archive and I look at how many stations are reporting at least one of those 5, it in the north of 55, it doesn't look too bad, actually. It looks like we've seen a long-term increase in the number of stations recording at least one of those variables. When you go to 2 variables, it seems, relatively stable. It wasn't as much in the early times, but then became stable. When you get to 3, then you start to see a decline. Obviously, there's a period where it was higher and then lower. And then you get to 4 and it gets even worse. And then you get to 5, reporting all 5. And you see just how few stations across the north there are that actually have kind of a robust amount of information available. And so this is another graphic. This just says out of the stations reporting anything, what percentage of them report at least 3 of the variables. And what you can see is that we went from having, probably less stations, but that, reported more things, to more stations that all seem to report a lot less in terms of information that's needed to support climate services. So to kind of provide a bit of a diagram of the problem is like you have these northern weather stations and they get used in real-time weather forecasting, and that's really important for extreme events. You need those stations for these corrected data products that we're told you need to look at historical climate trends, and also to think about what that means for the future. You also need those corrected products, or even the raw ones, to do the type of downscaling with climate scenarios to give local information about future climates. And so when you have an issue right at the start here, then you got to start thinking about how that filters out and impacts all these major things. So a lot of people who do northern work now use, I'm not going to go through it, but atmospheric reanalysis products. And they really, they provide, it's like basically weather models that simulate data from all kinds of different sources. And, they really are a massive gain and improvement over, having no data. But, I use them regularly. I've written papers on using them, but I still have to be remiss if I didn't mention that, like, where do people think the local, the local information comes from? It comes from these weather stations as well, right? Like, so if you're using one of these products for somewhere that doesn't have a weather station within 500 kilometers, I mean, it's a good first guess, I guess, but it's not the same as what's actually going on at that location. And I think sometimes the community forgets that a little bit. So yeah, that's, a real challenge. And, then we add in some extra challenges, and there's one that I want to talk about for a second. And, that's the real-time weather monitoring and forecasting piece of things. And I just want to point out that, the North also runs into major issues in that you have all these remote flying communities that don't have any sort of weather radar coverage provided by the government of Canada, right? This is kind of a map of current coverage, and I'm just going to show a map of, approximate coverage across Canada. And I've overlain the Nutrition North communities. So, the communities that are the most remote in Canada, especially all those in Inuit and Nunangat. But like you sit there and you look at this map and you see that there's very, very few that have any sort of weather radar coverage. And given that many of these are remote flying communities, like community of Nain in this case, that along the entire way, they don't have, they're going based on forecasts off of not a lot of climate information. They have no radar, so they don't know if they're going to encounter freezing rain along the way. They can't go over the weather because it's often like twin otters that can't fly that high. And so that leads to there being more likely to have delays and cancellations, because if there's the possibility of anything along the route, without being able to see if it's actually there or not, they have to err on the side of caution in a lot of remote communities. And so, thinking about the way this impacts how people's lifestyles, especially in Inuit communities, I mean, it's a real challenge. And I think it's time that in Canada, we think about grappling with that a bit. And, I was reminded of some of the challenges with data across the North, actually in relation to what happened with Fiona in Atlantic Canada, because it led me to look at like the real-time tidal information at one point, and you sit there and you look at it and you say, what, they don't get storm surges in northern Canada apparently, because there's, people use this real-time information when a storm's about to hit to see, oh, water levels are rising really quickly. You see it every time with all these hurricanes that come into areas and with big storms. But like, if you look across the Canadian North, I mean, you'd swear they weren't on the ocean. And just to provide this is a analysis that Dennis Gilbert had put together of storm surge estimates across Atlantic Canada using that real-time information. And you could see Port aux Basques there was around 1 meter. But, Port aux Basques there in southwestern Newfoundland, I mean, they were able to see, and I know people who were warning the community at the time that, like, we can see the levels are rising this morning, you need to get out. Well, what happened if that storm was a little bit farther north where they didn't have that real-time information? You might not have had the same level of warning in some cases as well. And so it's just something to think about in relation to even those other networks as well. I think I'm just going to give I was going to end with just a mention that we're trying to do some things to improve weather monitoring, at least in some of our remote communities in Labrador. And so we started a program oriented around setting up remote climate stations in communities that don't currently have them, and along some commonly used routes. And this was done, completely in collaboration with local Indigenous governments, and particularly the program was proposed with a lot of support from unanticipated. And this program began with trying to identify high priority zones for weather stations. And there was a lot of them, areas that didn't have coverage, quite a number of them being flying communities. And so we established some weather stations. It was quite an endeavor. And these are satellite based and provide near real-time information. And it's been a bit of a work in progress, but it's better to have them than to not in this case. And this is what 7 weather stations looks like, if you're wondering of this kind, at least. And this is one of the weather stations that was established in 2019 that we set up in the community of Black Tickle, which is one of the most remote communities in Labrador. Just an example there. So the 6 that we did set up were all established in 2019. And then we had another that we were meant to set up a couple of years in a row, and it's in the Inuit community of Natoshish. And we've just had a lot of issues with COVID and being able to set that up, but we're really hopeful that we can get it set up as soon as possible. And this is kind of one of those things we do regret, is not getting it done in the first year because of everything that kind of happened after. Now, we provide this information in a variety of forms, but we've got a partnership with Smart Atlantic, and they provide it in a really cool website. And so that's great because, people can go in and look at their current conditions. But at the end of the day, we can integrate our information into other sites, through the SIKU portal as well. But what people want is for this information to come through in their Environment Canada current conditions and their forecasts. That's what people in communities are using mostly. And we have up to this point had a lot of challenges in trying to get that to happen. The other thing that I don't think, some people are maybe aware, but those who spend a lot of time in the north and on land are certainly aware that a lot of people are now using products like Windy. They're combining their Inuit knowledge, their traditional Indigenous knowledge of the landscapes with some of these cool new apps, and using it to, I think, more safely travel on land. The thing about Inuit is they're certainly very adaptive and willing to, it's definitely something that's been integrated for a lot of hunters, especially using that kind of thing. So they'll take the marine forecast and, kind of pull it all together, and tidal stuff. But it kind of goes back to this core challenge of getting, you go and set up a weather station in a community, But if it's not being taken in by Environment Canada, by the Meteorological Service of Canada, then, you know, that's an extra website people got to go to. And it certainly doesn't, you know, we don't provide forecasts from this, and that needs to be done by the modeling groups and stuff. And so that's just something to think about as we have all these stations popping up. And we're slowly, after almost 3 years, we're slowly getting our information starting to be ingested at Environment Canada, but it has been a huge effort. And so if you picture how tough it is for an, you know, academic individual with all these ties to people working there, imagine how hard it is for a community that just set up a weather station to get their information coming through the way they want it. And so with that, I'm going to just say that, you know, we do have some new portals that really do improve the availability of information and thinking about the future. But these large gaps in the north really impact climate service delivery, and especially in Inuit Nunangat. And so, you know, now we have all these satellites and better models and reanalysis and all that, but that's not going to fix this problem. And there have been people who I think have thought it would, but I think that was probably a bit of a folly. We also have all these networks springing up across the Arctic, and we need to have a clearer path for, you know, continuity of those weather stations, and also help with making sure that it's actually getting to people in the ways they need it. And I think that's something that has to be a priority thinking forward. I didn't put something on here about the radar stuff, but like, I mean, I do want to say, I mean, that's one of the most egregious, easy fixes that could be dealt with in adding weather coverage or weather radar coverage for the north. But I'll kind of leave it at that. So with this, I just want to end by, you know, once again, thanking all the project partners and especially CMOS for having me today. And I did want to suggest, well, I've got such a big group of people here watching this talk, that there are some projects out there that can potentially help with some things too. Like there's like the DRAW project at McGill that's like data rescue. And, you know, the more data we have about the past, the better we can prepare into the future. And, you know, it makes a really good class project, for instance, for some of those of you teaching like weather projects and stuff, to go in and, you know, work on old weather stuff and contribute to some of these databases. So I just wanted to mention that. And with that, I think I'm just going to say thank you and Nakumik, and yeah, I'm interested if there's any questions about this. Thanks.
Thank you very much, Robert. And indeed, there are some comments and questions. Craig Smith was the first to make a comment, and he mentioned that the lack of precipitation data in particular has been impacted on the homogeneous data set has been impacted by the automation of the precipitation network. Yeah. You and I have talked about that in the past, and I mean, when I retired 10 years ago, I looked after that network, so I have to take credit and blame for the financing wasn't there, and the automation of the network has certainly been something that's taking place not only in Canada, but around the world. Unfortunately, when it comes to precipitation, especially in the form of snow, automated snow observations, and Craig knows how I feel about that, is really a challenge. And it's one of the reasons when I came back to Atlantic Canada, I started the COCORUS citizen science program here in Atlantic Canada. I don't know how much there is in how many of those there are in Labrador, but do see any opportunities, even, you know, those stations you're setting up, of course, are automated stations, but what about community precipitation observing or permafrost observing, or the cryosphere, of course, is the biggest challenge. And have you considered community monitoring or any kind of partnership in that way?
I mean, we've considered some of those things, and you know, it is a good point that, you know, automation has introduced both good and bad, and especially in relation to snow, you know, that's one of the one of the kind of the most problematic areas, right? Community-based monitoring is being undertaken all across the North in various ways. The challenge is with variables like snow, and especially if we're thinking in terms of climate services, you know, a lot of these programs, like the real embrace of community-based monitoring in Canada has only really been in the last 10 years that you see a lot of these programs coming off the ground. So, you know, the ability for that information to, you know, be used and inform things, hopefully is there in the future. But, you know, when we're trying to understand and predict things for the future from a climate service perspective, it is a challenge when you don't have long-term information, especially with snow, because snow is so up and down every year. In terms of community-based monitoring of snow conditions, like in Labrador, there are some, you know, small groups that do some pieces of work, but you know, the sustained investment is part of the challenge. Is like, you know, you can't build these programs based on 3-year funding windows all the time, right? And that's I think that's a real challenge, is that you need organizations like the organization you've created to help shepherd it through. But you know, if you have one person who is really doing something in a region for 10 years and then they step away or whatever, then you kind of lose some continuity there. And that, you know, that's just one of the real challenges that comes with thinking about how to deal with snow in particular. But snow is not the only you know, part of this that becomes challenging, right?
No, exactly. And there's another really good comment from Aurelia Schonberg. She's at PKIC, and she's given a lot of links for you, and we'll of course be saving the chat related to some gridded climate data for the western half of Canada. Of course, it's not helping you in particularly, but certainly the approach has been done in the West using kind of a downscaling approach. So I thank Aurelia for that really good comment, and I'd encourage you and everybody to look at that. Matthew Asplin in Victoria was asking,
could I say something about that
Sure.
for a second there? So like, I think that's really interesting in the downscaling approaches there's a lot of them being used, and there's a lot of these new products out there. There is an easy solution to the problem we're dealing with some of those gridded stuff. I mean, we wrote some papers a couple of, 8 years ago on how you can use reanalysis to infill missing observations and then interpolate it across areas, and you end up with much more accurate than leaving out observations. And we wrote a couple of papers on that, and like we could half the error just by doing stuff like that. And so using homogenized products to, like, you know, inform the interpolation, all that sort of stuff is really a good idea, but we're limited by the network in some ways, right? And that's kind of some of the challenges that we speak to before. Go ahead. Sorry to interrupt there.
No, that was a good comment, Robert. And there was quite a bit of discussion around weather radars. I mean, you know, as I said, I looked after the monitoring network, and the expense of flying up there and having crews go up there to maintain weather stations, just one thing, and having flights canceled or people just sitting around airports waiting is big. So the whole radar question you asked is a really interesting one. So Matthew in Victoria asked about, you know, what would it take to get radars installed in some of the key sites up north, like Nunavut, Iqaluit, Cambridge Bay, where there's already a high Arctic research station and the like. And Sarah, who's with Environment Canada looking after Northern Weather Services, mentioned that, you know, we've just finished a $140 million weather radar upgrade. So whether or not the government of Canada would consider reinvestment, I had thought the capital cities in the north were going to get an X-band radar. I know there's been an X-band radar up there for at least research purposes. but I don't know. Is there anyone besides you lobbying for that?
I think there's been some. So first of all, when I usually show the radar stuff, usually the reaction from a lot of groups is shock, to be honest, that all these flying communities don't even have, like, we've got radar coverage that's like way poorly, we don't have an optimally designed, like if we were taking the same the same set of stations and distributing them perfectly, we'd have a lot more coverage, obviously, but we don't. So we've got lots of overlap for some areas and none for all these remote flying communities. What I would say is that I think that there's a lot of really great work that gets done at Environment Canada and at the Meteorological Service of Canada. I try to avoid like full-on criticism. I am critical of the decisions with the radar program to not the rationale behind not thinking that all these remote flying communities wouldn't be a priority for that level of investment. So this idea about having upgraded, we're investing so much money in climate services, we're investing so much money in climate adaptation all across Canada. It was a bit surprising that basically that radar renewal program was just to improve our radars in the south of Canada rather than to add coverage into the north. In the US, they have coverage in large swaths of Alaska. There is coverage in parts of Canada only because the coverage from the Alaskan side crosses the border. In the US proper, there is Doppler coverage for 98% of the continental of the southern states. So, I mean, it's not an unfixable issue. In terms of in the north, the question is, could you take an investment and put 5 weather radars to cover and cover a huge swath of remote flying communities, a huge swath of Inuit communities? You could, right? Like,
Right.
if you put a weather radar in say my hometown Goose Bay, you would cover the entire route to every remote community except one. And I know you can increase the power and potentially expand the range a bit. I know there's challenges with that too, but a couple strategically positioned weather radars would have been worth the investment far more than some of the things. And so I am a bit critical of that. I think it's quite doable. In fact, in some places, like my hometown is now road accessible and literally has a spot where there used to be a radar dome or where there still is a radar dome, but there used to be even bigger ones for Department of National Defense purposes, and a road going right up to it. Like, this idea about remoteness, I mean, that I don't know that necessarily is the reason in that case, but it is a challenge in other areas for sure. It's a difficult topic because I know people had best intents in mind with this stuff, but as somebody from the north, it's a frustrating thing because we get so used to not having access to things that sometimes we don't even know to ask for it because people always put up the stumbling blocks.
No, it's a really good point. Well, S-band is pretty expensive. I know McGill has done a lot of really interesting research on using vertical pointing X-bands, which you could put very cheaply in a number of communities. And because they point up, they use the fall velocity to determine what kind of precipitation type it is. And so, when you're looking at below zero temperatures and falling liquid precipitation, certainly, freezing precipitation can be detected quite effectively using vertically pointing X-bands. So I'm not sure if there's anyone actually connecting research with an affordable northern radar network, which would be a really fun thing to do. And I'd encourage you and everybody else to promote that as a big project.
As we think about the future, I mean, near 0 degree conditions are going to become more and more and more of a problem across the north. So the phase of the precipitation is going to matter a lot for transportation.
Absolutely, exactly. Serge asked the question about CoCoRaHS in the north as well, and Sarah again actually mentioned that this is something that is being considered, and finding volunteers is a big challenge. I had some discussions myself with school boards to introduce CoCoRaHS in the schools, and using that as a learning opportunity as well as observing strategy. So anyways, that's obviously a work in progress, but it is perhaps an opportunity.
In a lot of the remote field work stuff these days, people are using like trail cams, and now we've got Starlink is out there and other sources like that. We developed a technique using light sensors vertically arranged that you could probably develop a version that's kind of tied into. There's lots of different ways out there. I think we've got to, we can't, obviously in an ideal world, you'd want somebody going out and measuring, or you'd want, multiple SR50s deployed at stations and stuff like that. But like, we might have to, rather than leaving out areas, we might have to start thinking about if there's some creative ways to think about. It's like the volunteer networks are really important, but like my position tends to be that it puts a lot of onus on, we invest, and we haven't really had a question about this, but like we invest a tremendous amount in the weather monitoring or the weather forecasting and climate modeling side. And then we ask volunteers to go out and measure snow. So
exactly. It'd be interesting at our CMOS Congress in St. John's to actually challenge or have a conversation with vendors that are going to be there about what would it take for a collaborative research program to investigate the optimal kind of equipment to be used in the north for some of these observing challenges. Cedric made a comment. Thank you very much for the great talk, and wondering if there is a need for the prediction of wave-induced sea ice breakup and the extent of that in northern communities.
I mean, there's a huge need for it, and I think there's a lot of work that's been done with the Canadian Ice Service to partner with local communities on on local ice conditions around a lot of northern communities, and especially I think there's a lot of thought being given to now about thinking about the way that I won't call it extreme events, but let's just say like storms can, especially with the Arctic changing the way it is and sea ice changing the way it is, we are seeing more and more break of events induced by simply just having bad weather, right? And there are ongoing works in that, but I guess how you integrate that into kind of forecasting, I'm not quite like, I think that's probably a priority on the Canadian Ice Service side with trying to work with some of their partners. I think they've done, there's a lot of issues obviously with some of the work they've done. There's always a lot of issues with working with the north, but I think there's certainly a desire there to address northern focused questions, and a lot of movement recently in that way.
Exactly. Matthew also commented on the Starlink and the fact that broadband is much more accessible, taking that opportunity. And Sarah commented that there's been some discussion in clients in NWT as well, NWT with respect to radar coverage. David Huard wondered if DND might be interested in expanding a radar coverage in the north. Certainly, you see a lot of those stations you showed were DuLine stations, and I'm not sure what the plans are, but there is going to be some renewal of the DuLine stations, I think.
So one of the things that we'll mention as well, so I think obviously one of the challenges that when we look at climate archives, they're coming from a variety of different sources, whether it's, D&D run station, whether it's Environment Canada, whether it's whatever, but we had an issue in northern Labrador where north of the community of Nain, so like, probably 25% of Labrador, which is some of the most rugged 25% of Labrador, has gone down to one climate station because 2 were removed in 2017 by either D&D or NAV Canada, and one of the others basically said we would replace them, and they didn't. Right. So instead of 3 stations, there's then 1. And that station that is there is located in, it's probably one of the most poorly sited stations you could imagine in terms of representativeness. It's on a 500-meter tall cliff over the ocean, right? Like right on the edge, and it doesn't record everything. And so like when you look north of Nain, in Labrador, we've seen the issues that come with one group makes a decision, other groups say they'll deal with it and then don't necessarily, and then you end up now what used to be 25 years of data is now ended, and there's no observing. So there's not a single station in the Torngat Mountains National Park as an example anymore because of that, right? So
wow. So both Vanessa and Sarah, thank you for a really great presentation and reinforced some of the issues that you've raised with respect to data challenges and forecasting challenges. Bill Richards, he said there's one Kokoras report in Labrador today from Lansalou, and it's on the coast of the Strait of Belle Isle, so that's interesting. I didn't know that there was a Kokoras station.
I didn't know that either, actually, but I honestly, it's been a while since I've looked at this stuff for a variety of reasons. I'm also on parental leave now, so it's kind of interesting to hear that.
Great. So I'm going to conclude. Thank everybody for the wonderful questions, and we had a really good crowd today. Congratulations, Robert, on the great work you do. Congratulations on being a tour speaker, and congratulations on being a new dad. Before we joined you, for everybody who's still here, Robert was commenting on he hasn't completely adapted yet to doing remote webinars and the like, and also being a dad at the same time with an infant in the house. And the infant is either quiet or far away from you. So, but congratulations on your new little one.
Well, thank you. I really appreciate that. It's really appreciated, Jim. And I, want to thank everybody for attending. And also, I really want to thank CMOS as well for asking me to come out and do this, and for, people taking time out of their busy schedules to talk about these things. Excellent. Okay. Thanks again. All the best, everybody, and have a great day and a great winter. Thank you. Nakamik.